This is chapter 8, section 6, applications. In other words, that means word problems. So our objectives are we're going to solve word problems using proportions. We're going to solve word problems related to distance, rate, and time. And we're going to solve word problems related to the time it takes to complete a job. So our first example, it says, suppose that an artist expects that for every 9 special brushes he orders, 7 will be good and 2 will be defective. If he orders 45 brushes, how many will he expect to be defective? So the first sentence tells us our total. We have a total of 9 brushes. So I went ahead and used the words so we make sure we write up our proportions correctly. We set them up correctly. Of those 9 total brushes, 2 are going to be defective. And why do we care about the defective brushes? Because that's the question. How many will be defective out of a total of 45? So since we're doing defective over total here, we got to do defective over total. We don't know how many are going to be defective, but we do know the total is going to be 45. So we're going to cross multiply because we have a fraction equals a fraction. 2 times 45 is 90. 9 times x is 9x. So we divide both sides by 9. And we find out that out of 45, we estimate that about 10 will be defective. 10 brushes will be defective. Letter B. In a zoo, a ratio of adults to children is 12 to 15. So the word adults come first. That means there's 12 adults. Children come second. So that means there's 5 children. So the order of the words and the order of the numbers go together. If there were a total of 153 people in the zoo, how many children are there? So our variable is going to represent the number of children. Well, how many children out of a total of what? 153 people. Okay. Now, the first sentence, we have to kind of set it up the same way. We want to know how many children out of the total number of people. Well, is our total number of people 12? No. Is it 5? No. This is adults only, and this is children only. So our people is going to include both children and adults. So how many total people are there? There's 17 people. 12 of them are adults and 5 are children. And of those 17 people, how many are children? Because we have children over here. We need children over here. Well, adults to children, 12 to 5. That means there's 5 children out of the total group of 17 people. So now we're going to cross multiply. We're going to multiply 153 times 5, which is 765. We're going to multiply 17 times x. And then to solve for x, we're going to divide those sides by 17. And we have 765 divided by 17 is 45 children. And you'll have one of those in Hawks. So remember, if it's compared to total number of people, you got to add those 2 numbers together to get the first ratio. All right, letter C. It says Sarah rode her bicycle to visit her friend who lives 12 miles away. On her way there, her average speed was 7 miles faster than on her way home. Sarah spent a total of 1 hour bicycling. Find the 2 rates. So her total amount of time is 1 hour, right? So that sounds like distance, rate, and time, doesn't it? So she has 2 rates. So we have the rate there plus the rate back equals our time, which is 1 hour. All right, so basically so our time equals distance divided by rate. Because our distance equals time times rate times time. Well, to get time by itself, you got to divide the distance by the rate. So what is our total distance? Well, she drove both ways 12 miles. She had to ride 12 miles to get to Sarah's house at one particular rate. And then on the way home, she had to work. This is 12 miles divided by the rate coming home. Okay, so we know the distance. We know the distance is 12 on the way there and on the way home. And we also already know that the time is 1 hour. So now it says, what do we know about how fast she went? It says on her way there, her average was something, something, something. Do we know anything about her speed on the way home? No. So if this represents the way home, this is X, because we don't know how fast she drove home. But we know a little bit about her rate going there. Her rate on her way to her friend's house was 7 miles per hour faster than her original speed, or her speed coming back. So I want to know what's 7 more than our unknown quantity. So that is our equation, and you guys are going to have some very, very similar to this, and you're going to set them up the exact same way. So make sure you're taking good notes so that you'll remember how to set up your word problems. So now this looks like one of the problems we had in our last section when we have an equal sign. When we have an equal sign, we can cancel out those denominators. So the first thing we have to do is find a common denominator. So one thing that will always work is if we multiply our two unique denominators together. So our denominator is going to be x times x plus 7. So since we have an equal sign, we're going to cancel out those denominators. So there's our least common multiple. I'm going to multiply it by every one of our terms. Times 12 over x. So these are over 1. And then even past the equal sign, I'm going to multiply 1 times x plus 7. All right, so look at just the first term. What can we cancel out? Well, we can cancel out 12 plus 7 and x plus 7 and x plus 7. So that leaves us with 12 times x. Our second term, we can cancel out the x only. Well, that's going to leave us with 12 times x is 12x, and 12 times 7 is what, 84? And then in our denominator, 1 times anything is anything, right? So we're going to multiply x times x, which is x squared, x times 7, which is 7x. All right, so here's our quadratic. So we want this to be a positive number, which means we're going to combine like terms, and then we're going to move everything on this side of the equal sign where our 12x or x squared is, because we want that to stay positive. So 12x plus 12x is 24x plus 84 is equal to x squared plus 7x. Like I said, I want this to stay positive, so I'm going to subtract from 7x. I'm going to subtract 24. And then to set this whole thing equal to 0, I have to also subtract 84 from both sides. So I'm going to subtract 24x. Subtract 24x, I'm running out of room. But 7x minus 24x is negative 17x. And then I'm going to subtract my 84. And now I'm going to set this thing equal to 0 because I canceled out both of those terms, right? So now I need, two numbers that multiply to give me 84 and have a difference of 17. So I'm not sure. I can use my calculator. I can divide 84 by 7. And the difference of 7 and 12 is 5. So that's not big enough. So I'm going to divide 84 by 4. And I found out that is 21. So is the difference of 21 and 4 17? Well, it is. So I've just figured out what my two numbers are, 21 and 4. So this tells me the signs are different. This tells me the bigger number is negative. So my two numbers are 21 and 4. So negative 21 and positive 4. Now this is a quadratic, which means I set both of those equal to 0. So my two answers would be, if I add 21, 0 plus 21 is positive 21. If I subtract 4, I get negative 4. So once again, this is a word problem. So is it possible to go a negative amount of speed? That doesn't make any sense, right? So I'm going to get rid of this answer. And the only answer that makes sense is 21. I can't have a negative speed. So that means x does have to equal 21. Well, if we go back to our original problem, her average speed was 7 per hour faster than on her way home. So that means her average there, on her way there, her average speed was 7 miles per hour faster than on her way home. So that means on her way home, she went 21 miles an hour. And on the way there, her speed was 21 plus 7. So her other speed was 28 miles an hour.